Recording now. I think it says it. I did say start recording, but I can't see that.
Yeah, now it is. It is. Yes, it is. It is being recorded.
Right. So basically, whichever of you want to receive this recording can receive it, or these recordings. Right. I was talking about the online column here, consisting of the Navipack and Naviscan software packages. Navipack to the top here is our data acquisition and navigation package, whereas Naviscan is also data acquisition, but that is data acquisition of more sophisticated sonars like multi-beam, side scan, laser scanners, etc. The data acquisition being conducted from Navipack are of a more simple nature. That could be, for instance, a magnetometer or also a single beam echo sounder for that matter. So we're saying normally that Navipack is IVA's online navigation and data acquisition package, and Naviscan is a sonar acquisition package. I will explain to you why it is necessary to have two different packages. You may not understand the reason. I'm not sure that I understand it myself, but I think it's based on history. Navipack is actually when I started in this business, and I'm very old. When I started in the 80s, there was still a package, IVA package called Navipack. Naviscan didn't exist because there were no multi-beam echo sounders in those days, and this is some of the reason or some of the background. But I'll give you more details. Starting with Navipack, we've got the sensor data to the left here. These sensors are being interfaced into Navipack. Different I/O parameters can be set up, but either way, Navipack will time tag the sensor data upon arrival on the port that we have defined. Navipack is using the computer clock to time tag the data. In some cases, we are using this time tagging. In other cases, we're not using this time tagging, but it's up to the user to define when to use it and when not to use it. And of course, if you want to use the time tagging, then you need some method to synchronize the computer clock to typically GPS time, some accurate external clock that will synchronize your computer clock that Navipack in turn is using to time tag the sensor data. But time tagged upon arrival on the port. We have another way, and that is to let the sensor data go through the ATTU. This is an IVA product. Actually, this is an industrial computer with some MOXA boards, serial MOXA boards. Accurate time tagging unit is what this is short for. When you let the data pass through the ATTU, then basically the data is also time tagged here. But the difference between the ATTU and Navipack and Naviscan for that matter is that the ATTU has a Linux kernel. It's running on a Linux operating system. We normally call it a stripped down Linux kernel, which means that the operating system only has the part of it that is necessary to run the ATTU firmware. The ATTU firmware developed by IVA is running on the ATTU, and the only thing it does is actually to read the survey data on the port and passing it on or broadcasting it to, in our case, Navipack and Naviscan. Linux kernel allows us to take full control of the timing. NaviPack and Naviscan are, as you know by now, executed on a Windows platform. That's the only alternative we have. And on a Windows platform, there is a limitation in timing of, in the range of 10 milliseconds, one time sigma. You can say 10 milliseconds, that's not a lot, and that's true, it's not a lot, but it's still, if you're doing multi-beam survey, for instance, from a survey vessel, and you're rolling a lot, then 10 milliseconds difference between your roll from the motion sensor and the scan from your multi-beam is going to be visible on outer beams. No doubt about that. So therefore, it could be an advantage to use the ATTU to get a better, you can say, time tagging of your sensor data, in this case, the motion data. There are companies like Statoil in Norway that are simply saying that we are not allowing you to do survey for us without an external time tagging source. And then this is what we are proposing in that context. But you can easily do survey without an ATTU. It's not a must in any way. That's important to emphasize. The ATTU, of course, also has to have PPS and ZDA. It needs to know that it doesn't have time by definition. So you have to, on one of these ports from the MOXA port, you have to interface ZDA plus PPS so that the ATTU can synchronize its clock to GPS time. And if you do that, then our investigations have shown that you can do time tagging with an accuracy of in the range of 50 microseconds. That's even very, very conservative. But that's, as you can imagine, 200 times better than the time tagging in that you can perform in a Windows platform. Time tagging is important, and we'll be talking also about that a lot. We've got NaviPack here, and we got Naviscan down here. So what is the difference between NaviPack and Naviscan apart from data acquisition? Well, there are quite a few differences. First of all, you can see in the NaviPack here that there are different modules. So NaviPack is really a workhorse that can be used for many different things, not just acquiring data or navigation. It can also be used for truck management, for instance, 2D seismic, actually also for dredging, as a matter of fact, in combination with the Helmsman's display here, which is then showing the progress of the dredging. But there are different modules. But in this context, it's more important to say that Naviscan is quite simple, actually. It doesn't have, for instance, subsea navigation drivers. That means that if we want to use Naviscan to acquire multi-beam data, for instance, we need to have the navigation information from an external source. And this external source here is NaviPack, but it could actually also be from another external source. It doesn't have to be IVA software. There are some advantages by using IVA software in terms of timing, etc. But in principle, the position source could be coming from elsewhere. What you see here, you see the three arrows here. This is how NaviPack can support Naviscan. The first one here, run line control. That's a practical thing where whereby Navipack can control the logging in Naviscan. Navipack can send a control character and tell Naviscan to start logging. This is typically done or activated by the user from the health science display here, where you press a single button saying start survey. Navipack will then send a control character to Naviscan, and Naviscan will start logging. Navipack will also start logging. So this is a method whereby you can control the logging in Navipack and Naviscan, or start the logging and end the logging in Navipack and Naviscan at the same time. So that's more like a practical thing. The position, of course, is very important. You're sending the position of the RV, for instance, to Naviscan, because Naviscan doesn't know where the RV is. So Navipack does know, so it's sending that position to Naviscan, and Naviscan is then using it and logging it together with the multi-beam data and gyro motion, etc. Whatever data we have defined in Naviscan. We're defining Navipack and Naviscan. You're defining the RV in Navipack and Naviscan. That means there are some sensors that will be defined both in Navipack and Naviscan. That could be motion sensor. We could define an Octans gyro motion sensor on the RV in Navipack, but we also need it in Naviscan, that motion gyro information coming from the same source. So I can say we can always split cables, but we want to avoid splitting cables as much as possible. So what we are doing is we are interfacing this Octans gyro motion. This is just an example into Navipack, and then we're instructing Navipack to send the same data to Naviscan via a LAN type of interface, or maybe an internal UDP type of interface. This information that we're sending to Naviscan is time tagged. So we have the same time tagging on this data that's being sent via the shared ports as we have in Navipack. So basically, the shared ports is a very smart functionality because it can be used to automatically send required data or selected dedicated sensor data to Naviscan. And at the same time, this shared ports allows us to configure Naviscan automatically. More about that later on, but this is an important part of what we can do in the Navipack-Naviscan relationship. So a lot of people are asking, can these two pieces of software can be executed on the same computer, or do I recommend that they're executed on separate computers? So what is the experience with this? Well, basically, we don't have any recommendations, because the experience is that if you set it up correctly, then it doesn't matter whether you have Navipack and Naviscan executed on a single computer or on separate computers. It's a little bit easier to configure it on a single computer. And of course, if you do that on a single computer, then you have to have an adequate number of monitors so that you can see what's going on, both in Navipack and Naviscan. But apart from that, there is no preference or no recommendation. It really doesn't matter. And so why do we have two? I think I have more or less explained it to you. This is based on there's a historical background for this. What I can also say, and I've said that for the last 10 years, that there are plans to implement Naviscan into Navipack. And I'm not going to give you any promises, but I hope it happens shortly, because it's a little bit, you could say, unnecessary. Why should we have two different packages? But there's also some conservatism, you know that. I'm sure there's some conservatism in the industry. There are certainly users that prefer it this way. But of course, for new users, it is a little bit awkward. Right. Now, I haven't talked about the HealthSense display. That's this one down here, HealthSense Display 4, installed with NaviPack. And this is actually a very important part of NaviPack. As you have seen on the e-learning, HealthSense Display allows you to control NaviPack and also Naviscan via the runline control. In the HealthSense Display, you can create an online DTM. You can see things in 3D, and in many ways, this is a very sophisticated tool, of course, but also a very important part of what we'll be learning during the next 2.5 days. We also got this is mentioned here, the HealthSense Classic. I'm not going to talk too much about it. It is installed with NaviPack. This is the old 2D HealthSense displays. Some of you that may have experience with NaviPack have tried to use it, but basically we're not really using it anymore. It's there, and sometimes when I'm doing QC on new implementations in the HealthSense Display 4 and NaviPack, as such, I run the HealthSense Display just to see how it was in the old days, and see if there's still compliance between what we can do in HealthSense 4 and what we used to be able to do in the HealthSense Classic. Of course, we should be able to do more in HealthSense 4, yes, but we shouldn't lose any functionality by moving it from this 2D environment to a 3D environment. Logging of data. In NaviPack, we're logging ASCII files, the extension NPD. We can allow ourselves to log ASCII data because the amount is a lot smaller than what we have in Naviscan. We have 3 different formats, and I'll of course come back to that later on, but it's also explained in the e-learning module. In Naviscan, we're logging the so-called SBD files. This is a proprietary IVA format. Scan binary data. This means NaviPack data. Just a single file logged in Naviscan. If we move on to post-processing, we'll always be starting with NaviEdit. And of course, the NaviEdit is based on a Microsoft SQL database or a SQL server. NaviEdit, you can say the typical flow in NaviEdit is that we start by importing, then we do editing. Part of editing could be the cleaning, and then we do export. But the main flow is import, edit, export. For the import, there are many different, you could call them interpreters. You could also call them importers. And of course, the 2 important ones, at least seen from our perspective, is the multi-beam interpreter that understands the SBD format logged using Naviscan, and another one is the NaviPack interpreter or importer that understands the NPD format that we have logged using NaviPack. There are also a lot of other importers. from third-party software. A good example is the so-called .all format that is logged using Kongsberg SIS seabed information system, and we have interpreters for that as well. We can also import simple ASCII files that could be tidal data or some velocity data, and for that we have a special ASCII interpreter. But either way, whatever we do, when we go to Naviedit and we start Naviedit, it's important to understand, and this is the way that Naviedit is different from perhaps other post-processing software packages, is that Naviedit starts from scratch. Naviedit has its own engine, or rather engines, because there are different engines. And what Naviedit is expecting as input, and we're not talking about the format, we're talking about the contents, is raw data. Raw sensor data or close to raw sensor data. And then basically Naviedit will use its engine to, first of all, visualize data in Naviedit, but ultimately to export data so that it's seen in Navi model in, for instance, a digital terrain model. But basically, it's not using calculations done online in Naviscan at all. It is taking the raw data and doing its own calculation. And there are great advantages involved with that, because that basically means that we can, well, first of all, start from scratch, but that it also means that we can edit things on sensor level, first of all. And secondly, we can edit all the configuration settings like offsets, fixed latencies, tidal corrections, sound velocity corrections, etc. All that can be applied in Naviedit. That also means that online, the online surveyors, their main concern is not to get really, really good data. Well, of course, they have to get really good data, but that is really good raw data. It doesn't matter online, do I have a good sound velocity profile, or do I have a good CTD profile, or anything like that. That's not so important, because I will redo everything anyway in Naviedit. What is important is that I do acquire a good sound velocity profile that I can use in post-processing, but I don't have to have it online. I can do it online, but I don't have to. It's not a must. When we talk about good data online, you can imagine that if you have your navigation, you are combining two transponder positions on the RV with a Doppler velocity log, then you get a really, really good online INS kind of position, and that's good online. But in post-processing, it would be a lot better to say, okay, I have my raw transponder position, I have my raw DVL data. I want to combine it in the way I think is the best possible way in Naviedit. So your job as an online surveyor, because you're going to be online surveyor here, is to acquire good raw data, and at the same time, of course, also show the RV pilots or whoever is using it good online data. But in post-processing, it's the raw data that we're using. I've already mentioned editing in Naviedit. We have two different editors, the header editor and the data editor. Header editor allows you to do editing of well, you could say your configuration settings, offsets, latencies, sound velocity profile, title corrections, CTD corrections, etc. All of that can be done and modified in the head editor. Geodesy can be changed here as well. And then we've got the data editor that allows you to edit data on sensor level. If you open a file in the data editor, you will get a window for each sensor, and then for each sensor there are tools that you can use to modify that particular sensor data. We're logging ultimately, or saving the revised raw data and header data in the SQL database, and as soon as we export to Navi model, it's using the revised sensor data and configuration settings, and not before. That means that any calculations will not be done and are not necessary until we export to Navi model. I'm going to skip the cleaning here because that's identical to the cleaning, at least some of the cleaning we can do in the Navi model. But exporting can be done in two different ways. We can export like we did. It was the only option 10 years ago. We would export to a file, series of files, and these files could then be used in Navi model, for instance, to create a terrain model. Nowadays, we're normally letting Navi model access the SQL database and dragging data into Navi model and creating a terrain model. When we do that, I've already indicated it, it's using the Navigated engine to create the, well, basically XYZ data down here in the Navi model environment. But it means that even in Navi model, we still have, well, raw data available, which of course is a good thing. That's what we want to do as much as possible, to remain or to keep the raw data for as long as possible. If we go to Navi model, Navi model is a little bit like NaviPack. It's also a kind of a workhorse. It's used for many different things. You've already seen one of the things, that's the Hellspan's display, because Hellspan and Navi model are really one and the same code. It's just your licensing that differs. So basically, if you're a Hellspan's display expert, you have got a really good start on your Navi model, and vice versa. Different tools here. Cleaning, we can clean DTM data, but we can also clean point clouds, laser scanner data, and that's what you guys will also be seeing. One of the exercises will be cleaning of point clouds. Another exercise will be cleaning of multibeam data. We've got DTM tools, different DTM tools. Navi model is actually quite sophisticated, but because it's using, it's creating the terrain model using the quad-tree principle, and that basically means that you're saving and creating your terrain model on the hard drive, and then you are loading data from the hard drive with respect to the location you are and with respect to the scale that you're using at the moment. And you will see that this is making Navi model quite sophisticated in terms of showing terrain models. We can have different, we call them surface types. A single terrain model can have several surface type. If I tell you that one surface type is an average model, another one is a median model, maximum, minimum, etc. And these can be in a single terrain model, and you can toggle between these surface types seamlessly. Single click in Navi model, then you are swapping from average model to maximum model, etc. And that's really very easy to do. We have pipeline inspection, post-processing tools, and Navi model. We'll be talking about that. That's also one of the most sophisticated parts of what Navi model can do, and it's I think it's fair to say that this is something that is used intensively by a lot of companies throughout the world, this pipeline inspection. Yeah, patch test calibration. This is going to be your first experience with Navi model, the patch test calibration, the multi-beam calibration. The flow is really that we have some SPD files that I have given you or sent to you. You've downloaded it from the FTP side. We load those into NaviEdit, make a course editing of the data using the header and the data editor. Then we load the data into Navi model, clean it, write it back to the SQL database, and then we do patch test calibration on the data. So basically, this is a standard flow, and it's really fast. You will see that it's fast. Of course, for us, it's going to take some time because I will have to explain to you what's going on, and you're not experienced, so you haven't tried it before. But of course, you've done the e-learning, the patch test e-learning. So you should know a little bit about what's going on. I got Navi plot at the bottom here. It's really a simple, what you see is what you get piece of software. And in this training, I'm using it to show you what it is that we're exporting from Navi model. So it's really a viewer of our Navi model exports. We'll start by creating a simple plot, but I'd like us to use, as I mentioned before, the chart layout manager that allows us to create a series of charts simultaneously. That's well, in terms of NaviPlot, that's quite sophisticated, as a matter of fact. And then ultimately, we will create a PDF file that contains a number of plots in NaviPlot. Yeah, this is the scope seen from the data flow view here. We can see NaviPack, NaviScan, NaviModel, and of course, NaviPlot is also going to be part of it, but I haven't included it because it's really primarily used to learn how NaviModel is exporting data. Right. Let's have a quick look at the different packages. This is the Helmsman display in NaviPack. We can see that we have an RV here, progressing, acquiring multi-beam data. You can see these are actually dots, small dots. These are scans, and then Helmsman's display is using these scans to create an online terrain. This is actually the online terrain model. You can see that there's quite a lot of noise here, quite normal. Of course, you see navigation is maybe not so good. but it's not a problem. This can be easily handled, and so that we have a really straight pipe, because this is a pipe. So this is a pipeline survey. A few other things, you can see that we have a left-right indicator here. It's telling us that the RV is 1 meter 80 to the port side of the run line. So the RV pilot should steer to starboard 1 meter 80, then he will be there. To the left, we have 3 windows here. Project tree window. This is a window that I always keep open, both in the health science display, but also in Navi model. It really tells us something about the contents of the current health science display project. If you highlight one of the items here, then you see the properties down here. It's a little bit difficult to see, but you can modify some of these properties online. At the bottom, we have the vehicle control window. This is the window that we can use to associate an object, that could be the vessel, for instance, with a run line or a waypoint. Once we've done that, then we can press this icon here and start logging. So vehicle control window is also very important. Yeah, there's also some toolbars, but we'll come back to that later on. The configuration, NaviPack configuration tool, basically shows you in different views our current configuration, both in terms of the objects. This is the main vessel, Atlantic Guardian, and in this case, there's a towfish, but you've also got sensors shown here, subdivided into different headlines like surface navigation, gyro motion, data acquisition, dynamic positioning. That's a USBL system, or 2 different USBL systems actually, and then data output. There could be others. We've also got down here at the bottom some POIs. We used to call these use-defined offsets, but nowadays they're called points of interest, but they are actually the same thing as use-defined offsets. All of this here can also be accessed from the menu to the left here, the project menu, the tree window. Main note here is vehicle, Atlantic Guardian, that's the same as this one here. And then underneath you have the first subnode is equivalent to the headlines here, surface navigation, gyro motion sensor, data acquisition, etc. And then underneath, we've got the instruments that are defined. And then further down, you can see that there are some other objects like towfish, tailfish, we can't see that here, front electrode, aft electrode, etc. This is actually electromagnetic seismic configuration. This one relates to. You can see different colors here. Different colors are related to different IO mode settings. The first one here that's highlighted, that's light blue, tells us that this is the current, this is the one that we have selected. And that means that the properties here are related to that instrument. That's in IO mode simulated. Simulated are the ones that are curry colored here. The only one that's not curry colored is the one that's selected. These are in off mode. This one is in on mode. And yeah, basically very useful because it gives you a very fast overview of what you have done. We'll be seeing a lot of that, but on the properties to the right here, you can see properties that can be modified. Some of it cannot be modified, as you see here, but basically they are included to give us information. Yeah, let's go on to Naviscan. Is a typical Naviscan online scenario. So the main thing about Naviscan, of course, is to acquire sonar data. You could say second priority, or maybe that's also first priority, is to give us enough information to QC whether or not the data is okay. We've got a window over here that's called the IO window. That gives us something about, yeah, you can see it, rate, how many inputs per second are we receiving. This is the latency of this, and of course, latency is not a problem, provided we know what the latency is, and provided we know it with a high accuracy. Time series of gyro, roll, bathy. This is a position plot. This is a cross section of the multibeam data. You can see this is a dual head Rayson 7K. Two heads are color coded. I did that. Naviscan doesn't do it automatically. You have to do it. So starboard side green, port side red, and then the overlap. Of course, this is the important part. Are they matching? And they are, as you can see here. Down here, we have a point cloud. And of course, this point cloud is the one we saw in the health display and being created as used to create a DTM there. This is the head editor. One window per sensor. Some of these sensors are even subdivided into the motion sensor, for instance. Gyro, pitch, roll. It's probably also heave somewhere, even though that's not used in subsea scenarios. But each of these windows have dedicated tools. This is the track or the navigation. And here I have chosen to superimpose the multibeam data on it. That's not there by default, but you can do it. And that's could be very useful sometimes. Yeah, let's continue with Navi model. This is actually the same data, but that we saw before, but this time it's been cleaned. Both the multibeam data, but you can also see the navigation is pretty straight, which is what we're expecting. Well, you can't see the navigation is straight, but you can see that the pipe is straight, and that's what we're expecting. You can also see the RV here, and then at the bottom, we have video. So this is video integration that was done here. This is VisualSoft video. And basically you can say, how can we do that? Well, basically the trick is to have something in the map view window. This is called the map view window, also in the headless display, something that can link position to time. Because the video is time-based, obviously, and the map view is position-based. We're using the track. This is the line you see here. This is the track. The track has time and it has position. So basically, the RV, can't see that, but the RV is somewhere here. It has time and position. Navi model knows the starting time of the video and it knows the frame rate. So based on that, it can calculate the correct frame to this time, and then it will go there in these video windows. Yeah, that's KP access window. That's very useful. Different thing. You can see the exposed pipe here versus KP. This is where we have exposed pipe. This is where it's covered. It's covered here. Yeah, very useful. And this is also what you'll be seeing. This is NaviPlot alignment sheet. This is actually the user interface of NaviPlot. You have the project to the left here. And then you have the plot shown in or with a what you see is what you get approach. So this is basically what you can expect the plot to be looking like when you create it. Alignment sheet. So our KPs are the same in the vertical direction. The bathymetry at the top here with a geotiff of the multibeam data. We've got the run line here as well. It's not shown that much or that clear, but that's basically the carrier of the KP information, and then it's aligned, or rather the longitudinal profile that also has KP is aligned to the run line up here, or the KP information in the bathymetry window, and the same for the cross profile, and down here we have an events profile. There's a key plan here that shows where we are, which plot is the current plot. Right. Different applications. Yeah, this I think speaks for itself. We'll be, of course, focusing a lot on this one and that one. A little bit on side scan surveys. A little bit on pipeline cable route inspections. Yeah, and that's more or less it. You've already seen the download site, but I need to tell you about it because everybody can access it. See iva.com, and then you go to the download site there and go to NaviSuite, and then you got the different packages, and everybody can download and install, but they cannot necessarily run the software without a license, that is. FTP site, some of you have used the FTP site. Maybe I should upload this this slide here because we've experienced that an increasing amount of people that are having problems with accessing the FTP site. With, as you can see, I'm using Windows Explorer. Could be some problems with that. So we're using FileZilla, which is basically an FTP client. So that's also what I wrote to you guys, that this is our recommendation that you do that. But anyway, two folders, download and upload. Download is for you to download. Upload is for you to upload. And of course, I can access everything if I want to. But basically, you've seen download. I'm uploading data to you in this folder so you can download and use it. But if you have a problem and you have addressed this problem to IVA support, and then you have large data sets or data files in support of this problem, then you can upload these files to the upload folder. That we're doing that quite a lot. You can see there's, well, company names here. That's how it's done. The only thing people have to be aware of is the fact that everybody else can also see that data. So they can upload, and then perhaps they will find it's a good idea to delete it immediately after that. Documentation side, you've installed the documentation side. The whole idea is that the documentation side can be installed on your computers. It contains all documentation and training material associated with the hardened software. Don't have to have an internet access. That's probably the main advantage. Also, the fact that there's everything. Different packages have different pages. This is the one related to Navi model. There's also one related to NavPack 4. And of course, also the other packages. We've got the alternative to that is FreshDesk. I have a FreshDesk. This is found on the IVA website. That is, if you can find it. Let me try to show you how that is done. IVA.com. Yeah, you can see there are different sub pages here. This is the download side. This is the support side. And then you go to support ticket system. And then here it is. This is FreshDesk. Subdivided a little bit differently from the documentation side. But a lot of the documents that are the same, but also a lot of documents on the documentation side that are not found here, and vice versa for that matter. Let me see if I can find. Yeah, pad test calibration. Oh, hell. Oh, there it is. This is the pad test calibration PowerPoint presentation. Let me see if I can find the equivalent on the documentation side. I pressed the wrong. This is the documentation side. Yeah, I pressed the wrong icon. But documentation side, the software, Navi model. You can see there are four documents on the FreshDesk, but here you have a lot more. And one of them, of course, is Navi model patch testing. Exactly the same document here. So basically what you can expect in the future is that more and more documents are moved to FreshDesk. But you still need to have an access to the internet, which is not always the case when you are offshore. I'm not going to detail more. You guys have seen this, so and that's part of the notes that I sent you. A single comment on this one here is that disable firewall. Basically, that's only something you do while you're installing the software. This preparing the PC for Navi Suite. I don't even know if that's part of the notes I sent you. I don't think it is, because this is important when you're if you have an online computer. Don't synchronize that to internet time. If you have a requirement for high timing accuracy and you have set up a ZDA plus PPS synchronization, because then there's going to be a conflict, obviously. So this is something to bear in mind for you if you are setting up an online computer. Yeah. Installation. Now, guys, I hope you're ready because I'm ready now to start using NaviPack. There's no reason to continue showing you all of this in a PowerPoint presentation. Yeah. NaviPack. Open. See, I have a NaviPack. There it is. I made a shortcut down here, as you can see. Now, I'm fully aware that yours doesn't look like this. It probably says something about test setup or something like that. There's a default configuration that's being installed so that you have something to look at. But this is you can see that NaviPack will always open the most recent configuration. This is a configuration I was using last week I was doing e-learning on talk management, as a matter of fact. So this is a talk management scenario with a barge and 2 talks. Yes. And all the instruments are repeated over here, and all the objects are also seen down here. Not a very complex, at least not in terms of the configuration, but apart from that, it actually is quite complex. But I would like you all to Stephen, that's okay. I'm answering a question regarding. You can just install 453 in the afternoon and then use the same configuration. And anyway, your exercise of the afternoon will actually be to finalize this configuration, the one that we are starting now. Let's start by creating a new setup. Press the icon here at the top left corner or choose File, New. And basically everything disappears. And the only thing we have is a configuration with a single object. And that object is the main vessel. There's no point in doing a NaviPack configuration unless we have a vessel. So that's always there. We can start by giving it a name. You can call yours whatever you want to call it. Virtual. No. On off. Like this. So we've got a vessel, but we haven't got any instruments. So, first thing to do is to apply instruments to the vessel. right-click in the rectangle here and choose Add Instruments. This will give you this dialog here. At the bottom, you can see that there are 439 items. And items in this context are the drivers. It's referring to the drivers. We have 439 different instrument drivers defined in NaviPAC. And of course, we will start by introducing a surface navigation instrument or defining a surface navigation instrument. You can explode surface navigation. I think that's the easiest thing to do. And then you can choose this instrument down here, GPS1 NEVA. This is like a predefined NMEA GPS instrument that people are using more or less all the time. There are also other drivers. There are some range bearing systems, total stations. Yeah. But apart from that, it's even some radio positioning instruments here, Salides XY. But they are rarely used. Let's use this one here, GPS1 NMEA. Say OK to it. The first thing that then pops up is the I/O selector. We need to define the input-output parameters. As you can see here, NaviPAC is supporting different I/O types. Serial, of course, that's a serial port. UDP, TCP. UDP is UDP-IP protocol, TCP-IP protocol, and ATTU is a input type that supports the ATTU format that I was talking about earlier. In this context, we're using serial. We'll also be using UDP and ATTU later on, but for now, we'll use serial, and the reason for that is that serial simulates. NaviPAC doesn't really simulate the UDP IP protocols, unfortunately, but it's not really a problem. I use COM2 here because I want to use COM1 for something else. Notice there's a tick mark on the show unavailable, and that's because otherwise you guys wouldn't have any COM ports. I assume that's certainly not normal to have COM ports on a laptop or whatever it is that you're working on. See, I actually have 4 COM ports down here. That's because I have a USB to serial port on my computer somewhere. So I actually have COM 6, 7, 8, and 9. But I'll use COM2 for this. I'm not going to change baud rate. I'm not going to talk about parity, data bits, and stop bits. But of course, if you have a physical instrument, then you can press connect, and then you will see data coming in here. And you can see whether it makes sense. If there's a lot of mumbo jumbo, then you can change the baud rate or parity, data bit, stop bits until it looks correct. Once you've done that and press OK, NaviPAC will remember the settings. But I will use COM2 because I need COM1 for something else. I'm going to use COM1 for ZDA PPS. We'll come back to that later on. Okay, first instrument, GPS1 NEVA. And to the right, we have the properties. We can start by, you can see that the name can be modified. You can see it's a clear white letters here, but you can also see that the name is inherited from the system name. This is the driver name. So name, change this to primary GPS because I'm going to, at a later stage, I'm going to change and add another GPS that I'm going to call secondary. Name changes immediately. Instrument ID 44. Well, let me try see if I can find the documentation side again. NaviPack 4 instrument parameters here. This document. Yeah, I'm always doing this the wrong way. Not that one, but this one, sensor interfacing. Sorry about that. But this is sensor interfacing. That's the well, certainly one of the most important instruments related to NaviPack 4. You can see here that, well, if we look at the contents, you can see that there are instruments or headline associated with each of the headlines for the instruments here: surface navigation, gyro, motion, etc. Surface navigation, instrument, and IVA ID. And this is the same as the instrument ID that you see over here. Down here, you see IVA ID 44, GPS 1 NMEA. And then there's a description of what you can expect and what you can do with this driver. You can also see that the driver actually shares the description with 4 other drivers: GPS 2, GPS 3, GPS 4, GPS 5, NMEA. That tells us that we can only use GPS 1 once. Then we have to use GPS 2, but you don't have to worry about it because it will disappear from the available list once you've used it. But the reason for that is that for each of these to work properly, you can define say dedicated settings, and these settings can be different from the 5 different drivers here, and that's the background for this. But any instrument ID, you can go and find it in this document that's called sensor interfacing here. That can be useful at times for debugging, for instance. Now, next one is info. And if you look at it, you can actually also see that most of the time, the help text that you have at the bottom here is giving you valuable information about the settings here. Of course, you cannot really do anything here, but you can say that these are prefixes that are being supported. GGA, for instance, a GGA string can be used here. Offsets, next one here. If you highlight it, you can press the browse button, and then you see the offsets. If we had some points of interest, they would be listed here, and they could then also be used just by clicking on it. Then it would inherit the offsets from the point of interest. Well, we type them in manually. I don't know if you saw at the bottom right here, enter offsets from vessel CRP. This is the common reference point to the instrument. So it's the vector from CRP to the instrument. X component is a cross vessel, positive to starboard. Y is a long vessel, positive forward, and Z is positive upward. So I would like you to use small values here. Let me just, I'm just opening a PowerPoint presentation. This is the related to your exercise of the afternoon, because in there I have specified exactly what these offsets should be. There's no reason why I should change that. So basically 0.55 and 17. So the horizontal part, the X and the Y, they're used, of course, to determine the whereabouts of the CRP relative to the GPS antenna. We're using simulated data here, and our simulator is not that intelligent. It cannot take offsets into consideration. So we'll use relatively small values. And of course, in a real scenario, you can use the correct values. That's not a problem. But here we'll use reasonably small values like this. Let me, just in case you should be in doubt, I can send it to you. Nope. There you go. So much for the offsets. You can see how they are displayed here in one line, comma separated. The next setup ID is, that's just a running number that NaviPack is using, starting with 0. So it's really an index starting with 0 and then continuing. So you can't change it. IO mode, on, off, simulated, calculated. On, of course, is when you really have data, you want to use it online. Off is when you want to keep a configuration, but you don't want to use it, but you want to keep it for future use. Just set it to off. Simulated is when we want NaviPack to simulate data for this particular instrument. And then calculated is when it is possible to calculate a value. A good example of a calculated or an instrument that can use calculated mode is if you have a gyro and you put it into the calculated mode, and you don't have to have a physical gyro, but NaviPack will simply use the course made good to give you a gyro value. We'll put this one into simulated mode. If I want to, I could change the IO information here. I don't want that. Then we got the next 4 are items that I will come back to. Apply datum shift. Use time and telegram. Apply ITF shift. Basically, we haven't defined any datum shift yet. We haven't defined any ZDA PPS, so time and telegram doesn't make any sense. And then an ITF shift which is used on top of a datum shift potentially, is not relevant at this stage either. But I promise you that I'll come back to it because we need to talk about geodesy, we need to talk about ZDA, PPS, etc. at some later stage. String details. Normally, you don't have to modify these. But of course, there are situations where you have to. Number of bytes, for instance, that's the number of characters, 200. Well, basically, that should be enough for a GGA string, or more than enough. No reason to change that. Telegrams per cycle, the next one here. Help text down here says define the total number of telegrams per Navipack cycle. Default, a cycle is 1 second. If there are more strings, then they'll be discarded. So if your GPS outputs a position with an update rate of 10 Hertz, and you have a Navipack cycle of 1 second, and you have specified 2 telegrams per cycle, then Navipack will only read the first 2 and then ignore the next ones here. So this is something you should be aware of. What I would say is that if you have knowledge about number of telegrams per cycle, for instance 10, then you should enter 11 here, just to have an extra one at the beginning or at the end or whatever. But for now, I would like it just to keep 2. It doesn't make any sense. It won't output more than 1 per second. This is the simulator anyway, so it won't make any difference. We've got something here called driver type. 5 different ones here. And of course, this is a predefined driver, so there's no reason to change it. Prefixed ASCII string with carriage return line feed. The prefix is the one that's been defined down here, $GPGGA. Yeah, I'm just looking at Kuram's question. Oh, basically, when you are setting up an instrument, then you should know what the output rate is from that particular instrument. In Navipack, you can see what the output rate is when you go online. Then you can see how many telegrams Navipack has received per second. So that's quite easy to see online. But this is also something that I like to come back to when we start talking about motion gyro data, because that's where it becomes really important to have adequate data there. Now, string prefix $GPGGA, and of course this has to be in compliance with what your GPS is outputting. If your GPS is not outputting this string prefix, then you should modify the string prefix information here. You could also modify it in the GPS, but it's easier to modify it here. $GPGGA. Doesn't necessarily have to be GPGGA. You can also just say GPG, because then it will take other telegrams that might not be just position telegram GGA. There could also be some other information. Let's just try to say $GPG here and see what happens. Yeah. Let's add a gyro then. This time we will use This time we can try just to use the filter settings up here. Type in octans. And then you can see that there are 4 instruments that meet this filter here, octans. 4 out of the 439. Remember, there were 439. Now there's only 438 because we've used one of them. We cannot use that anymore. Choose this one here, octans gyro. You can say that the next in line would be COM3, but I would like you to use COM4 because that's what I have specified in the training here, the exercise document. COM4. Here it is. Again, we have the properties to the right. I don't envisage changing the name. Instrument ID is 117. Let me see, just for the last time, let's try to open this one here. 17. There it is. Octans gyro. Not so much to say to that. Ordinary NMEA $ATHDT. That's good, but you have to be careful, and I will explain to you why you have to be careful. But first, let's have a look at offsets. For a gyro, there's really no reason to define offsets. A gyro has, well, same value, or rather the vessel has the same heading wherever you are on the vessel. So therefore the gyro has the same value, irrespective of the location of it. I'll just leave that as it is. You see setup ID is now 1. This is the next in line. IO mode, simulated, IO, just keep that as it is. Next, here, gyro, C-O. You could say, you could call this a calibration constant. Basically, we're adding the value that we type in here to the raw sensor reading. Always, it also says so in the help text at the bottom here. Gyro, add angle. I'd like us to use 1 here. There's a reason for that, and that is at some stage we're going to have a secondary gyro, and we'll give that a different C-O value, and then when we go online, then we can see which one is actually being used, or is it an average of the 2 that's being used. So to be able to distinguish these 2 from each other, we give them different C-Os. Time slice, data reduction, as the help text says, downsampling of incoming data to defined interval. We're not going to do that. We're going to use all our data. This is a general approach, you could call it, because why should we limit the amount of data that we have? We want as much data as possible. That's certainly my approach, always. So I think the time when we were reducing data is long gone. We're not reducing data nowadays. We want to have as much data as possible. We can handle it online, we can log it, and there's no really problem with having as much data as possible. Next one here is interesting, latency. It says enter known latency of sensor input. That means NaviPack will time tag the data upon arrival on the port. But if we tell NaviPack that the data was already delayed when it arrived on the port, then NaviPack will subtract the latency from the time tagging and use that. I also have to mention to you, because that's important to understand, that when we are logging data, it will log the raw data and it will log the latency. So if you load the data into NaviEdit, you will see the raw data and you will see that latency that you specify here in the header editor. That means you can modify it there if you want to. Now, why am I talking about that? Well, it's important, firstly. Secondly, because this particular instrument actually has a latency. See if I can find document manuals, Octane's documentation. This document here. This Octane's subsea models, version 3, I think. Go to the last chapter, last sentence on the last page. It tells us that Octane digital data outputs have a constant latency of 25 milliseconds, frequency independent. I've already talked to you about 10 milliseconds. Imagine 25 milliseconds. That's something that you can really see. So it has to be taken into account, both online but also in post-processing. 25 milliseconds. How do we type that in here? This is, the unit here is seconds, so this is 25 milliseconds. Not to confuse matters, but if you have a newer Octanes, then the related manual says that the latency is 3 milliseconds. So that's a factor 10 better. Also notice that we don't have any decimals here after the milliseconds. I find that quite interesting because that means that they're not concerned about anything beyond the integer milliseconds. And we're concerned about, well, basically what Statoil is saying is that you have to have time tagging with an accuracy of better than 0.5 seconds. But basically you can't have that if you don't know anything about what the latency is beyond the integer millisecond. So that's, it is a, well, basically, I think latency and time tagging is a little bit of a gray zone area, external time tagging that is, but yeah. Anyway, number of bytes, 32, telegrams per cycle, 50. Seems like an awfully high number, but that's basically what we would like, what we are recommending as the minimum update rate when you're doing multi-beam survey. And this is on the vessel. And what you will see is that the survey that we are, or the configuration that we are going to make here is really linked to an ROV-based multi-beam acquisition. And of course, it's on the multi-beam object that we need to have the high update rate. And that is the motion sensor, the gyro, on the ROV must be updated very frequently. But the same we define for the vessel. There's no reason why we shouldn't. Telegrams per cycle, 50 hertz. And then what you see here is that the driver type is normal ASCII string with carriage return line feed. This is a little bit tricky because it's not a problem to do this, but there would be people that would say, okay, why don't we use this one here instead? Prefixed ASCII string with carriage return line feed, because after all, we know that it has a prefix. We can see that up here. I find that to be a very good question. I ask it myself, so of course I think it's a good question. But this is something that I will come back to after a short break, because I would like us to have a break now. I would go and make myself a cup of coffee, and then I suggest that we meet again 20 minutes past 11. And I'll also answer your question afterwards, Kuram, because the answer to that is, of course, no. Yeah, okay, guys, 20 minutes past. And what I can say is enjoy your coffee. I will certainly enjoy mine. And if you want to have tea, then that's also fine. Okay. Yeah, guys, I'm here. I'm here right now. I need to 2 more minutes because there's a guy who hasn't been able to access. That will just take 2 minutes. I hope that's okay. I'll be back. Okay, guys, I'm back again. I'll start the recording again, I hope. No.